Hi everyone. In this video, I am going to discuss our chapter 4 of our Introduction to Cybersecurity course, which deals with protecting the organization. This particular chapter is dedicated towards protecting the organization assets. In this module, we will be covering topics related to what do you mean by firewalls, what are the different types of firewalls, the different intrusion detection systems, intrusion prevention systems, and other stuff related to detection of attacks. How do you detect them first? What are the different security policies that can be implemented? So let's talk about firewall first. What do you mean by firewall? In networking terminology, a firewall is designed to control or filter which communications are allowed in and which are allowed out of a device or a network. It's like just like a gatekeeper function. So if you place a firewall outside of your network, it keeps on monitoring the traffic going in and going out of that particular network. So people might think, is firewall a hardware device or a software device? It can be either both. There are hardware firewalls dedicated for monitoring traffic, and there are some software firewalls which can be installed on the currently staying on network devices. So here, these firewalls, we don't have only a single type of firewall. There are different types of firewalls which does different levels of filtering at different layers. So based on that, we have different types of firewalls as listed over here. The first one is network layer firewall. Most of these firewall types, as their names suggest, are self-explanatory or at the level which they work. Network layer and transport layer, they work. If you talk about a network layer firewall, it works on filtering based on the source and destination IP addresses. If it is a transport layer firewall, it is based on the source and destination ports and also the connection states. Application firewall, the filtering is done based on the specific application program or service. There are other firewalls where we also talk about context-aware application firewall, proxy server, reverse proxy server, even a NAT firewall, network address translation, which is done to map a public address and a public and a private IP addresses, and finally a host-based firewall, where it is a firewall based on a single system. It is dedicated to that particular system. There are different types of firewalls. So the which one is to be chosen is actually based on the network administrator's idea of what to protect and how to protect. One thing is sure, that firewall is a device or it is a software which actually keeps on monitoring the traffic, incoming and outgoing traffic of your network. And if it actually detects any of these malicious codes entering, it will automatically stop them. So when we talk about ports, there is also something called as port scanning. We studied in our earlier networks that there are multiple applications that keep running on the system at the same time. Now, in order to distinguish these applications and also to properly deliver the data to the appropriate application, each and every one of these applications are attached to a port. Usually ports have numbers. There are many ports present, 65,000 odd ports. Now, port scanning is a mechanism which is used to search for the status of a particular port. It is done both by the administrator and also by the attacker. Usually, the administrator does the port scanning to see what ports are being used, what ports are being currently idle, those things. Similarly, an attacker can also do a port scanning with a malicious intent of identifying the different processes that are running on the system, or if there are any ports that are open which he can exploit and enter into the system. Basically, port scanning is not legal in most of the corporate companies or other large organizations. If you want to do port scanning, you cannot do without prior permission from the security administrator. There is a software tool called as Nmap, which will allow you to do the port mapping. So the Nmap scan will actually report any services that are running. There are three ways which you can get the output back from Nmap. It will tell you whether the port is open or not, closed, filtered, dropped, or blocked. It will tell you the current state of that particular port. But as I said before, if you want to run the port scanning from outside of your network, if you want to run a port scan of your network, you have to go outside of the network and then run your Nmap. Try Googling Nmap port scans and you should come across different snippets showing you how Nmap results look like and what information can you infer from them. Talking about security appliances, they can be standalone devices. As I said, security appliances are not just hardware. They can be software tools which are running on a network device. The most common security appliances that you see every day are your routers, firewalls, intrusion IPS, VPN, malware, antiviruses, and other security devices. Now, if we talk more, the thing which you should also be aware about is something called as a zero-day attack. I also told you in my earlier videos regarding vulnerabilities that no system is 100% secure. Obviously, there will be some vulnerabilities, but when a hacker actually exploits these vulnerabilities, even before the creator can fix it, or even the administrator can know, does have any information about it, that kind of attack is called as a zero-day attack, or sometimes it's called as a zero-day exploit. And you cannot guess whether it's going to happen or not, because it is completely up to the attacker to find out that particular flaw, or to find out that particular vulnerability, and then design an exploit to perform an attack. So because of the sophistication and enormity of zero-day attacks found today, network defense has become a very complex issue. So rather than trying to see these attacks do not take place in the first place, now the defense is now measured in terms of how good you are or how quick a network can respond to an attack. So an attack has happened. So how good your response is? How fastly can you respond? So the ability to detect these attacks in real time and also stopping them once you detect them, these will be the ideal goal for your network administrators. You cannot say that now I have taken all precautions, no attacks are going to be done. You cannot say that 100%. So obviously attacks are going to happen. Now your network defense team should think in a way such that if an attack happens, or if an exploit is there, some attacker has done a security incident happens, how good you are, how fast can you respond, how quickly can you detect it, and how efficiently can you block it. That is the way how our response is going to be measured, or how the efficiency of our cybersecurity team is going to be measured. But unfortunately, most of the companies still are very much in the backward part itself. They are not good enough to detect these attacks in real time. After a long time, once the attack has been done and necessary things have been taken away, only then the companies and organizations come to know that an attack has happened. So there is a lot of things that need to be worked out. This is primarily to the fact that there are not enough cybersecurity professionals who have got expertise in network defense. So maybe you guys can put an end to this. So coming to the next part of securing an organization, the best thing is you have to make it a habit of executing best security practices. So what are these practices? They are pretty simple. So you perform a risk assessment. That means if you don't want to spend 100 rupees on securing data which is worth only 10 rupees, right? There is no point in that. So perform a risk assessment. You have to know the value of what you're protecting, so that it will help you to justify whatever security expenditure you are spending in safeguarding that particular information. You have to create security policies. So this policy should clearly tell you what the company rules are, what the job duties are, what each and every individual is expected to do within that company, what they are not expected to do, do's and do nots. All those things should be placed in a security policy. The third practice is physical security measures. So lock the rooms. Don't allow any outsiders to enter into the premises. Allow only authorized personnel into the networking rooms, like your server rooms or any other data centers. Don't allow anybody else. Only proper credentials should be checked. No tailgating is allowed. All those things comes under physical security measures. And humans HR security measures include you do profound background checks before hiring someone. If you don't know, do a background check, see whether he is good or not, whether he has got any prior crimes, cyber crimes, anything, all have to be done. Next, perform and test backups. Make sure that each and every data is being backed up regularly or not, how the maintenance of the backups is also very important. Maintain security patches and updates. I have been saying from the start of this course, each and everything has to be updated. Software should be updated on a regular basis. Unless until it is updated, you will have a problem. There are updates are actually released to solve the problems that are identified earlier. So the other things is educate users. You have to tell everybody. Make sure that security plays a major role. Each and every employee of the organization should understand the necessity and need for securing or implementing best security practices. Encrypt the data, whatever sensitive information is there, you please make sure that you encrypt that data. Employee access controls. So as I told you earlier, so based on, you can actually put access controls based on user roles. So an low-level employee need not access the HR records. Only the management should be able to do that. So you classify the information that you have, and based on the level of information or the type of information, sensitive nature of the information, you assign the access controls to the users based on their roles. And also regularly test incident response. So do some drills. If an security incident happens, what is going to, how fast your reaction is, and also test the emergency response scenarios. Implement something, a tool which keeps on monitoring the network, gather all the data, perform analytics, and then report back. So you have to have something, a network monitoring and analytics and a management tool. And also implement network security devices, implement latest routers, implement firewalls and other security appliances, including some software which run on network devices or even on the host systems also. And finally, implement a comprehensive endpoint security solution. It might be enterprise level anti-malware or antivirus software. So these are all the security best practices. I'm saying, in order to, because organization is not just one individual or one system or only some sensitive data, it contains a lot of information systems. So in order to safeguard all of those things, having best security practices is the only thing which can actually protect the organization's data. We studied about botnets earlier. I told you that using this botnet is nothing like an attacker can sit in one position and keep on infecting different systems and turning them into bots. Also, we call them as zombies. And there is a command and control structure where he will be able to actually control these bots at the same time. I'm not talking about one or two. I'm talking about hundreds and thousands of systems which are infected across the world. And if the attacker wants to target one particular server, he can send a remote, he can actually remotely control them, and he can send a command to all these zombies to attack the server at a single time. Thereby, this server can no longer withhold that amount of traffic. So it will automatically crash, which will lead to a DDoS attack. Generally, what is happening nowadays is cyber criminals are actually renting out botnets for a fee for third parties. If they don't have any use for it, they can rent it out for somebody else, let them do the attack, and they will get back. They keep on infecting and they keep them with them so that they can rent these things out, just like cloud computing as a software as a service. They provide botnets as a service. Okay. And this is the most important part. How this is called as a kill chain. What are the different steps in cyber defense? In order to, for any network administrator to perform network defense, they should be able to understand what this kill chain is. What are the steps that are usually followed? See, in stage one, it is called as reconnaissance. So here, the attacker actually gathers information about the target. The second stage is something called as weaponization. Weaponization means that the attacker creates an exploit and malicious payload to send to the target. First, he will identify, and he will collect a lot of information about the target, what they might, what they are more likely to click, or what they are more likely to fall into trap for, all those information. And then he creates an exploit. The third one is deliver that particular exploit to the victim. Maybe send an email or send an SMS or what it is. And obviously, if you do the reconnaissance well, and if you plan your exploit well, the victim is most likely to click that particular, whatever you send to him, click the exploit. So the exploit will be executed by the victim. Once the exploit is executed, the next stage 5 is the installation process. So that exploit might contain malwares or a rootkit, whatever you send. So this malware will be executed on the system, and it creates backdoors for the attacker to enter into that system. Once the backdoors are created, the complete control of the system will be taken over by the attacker. That is called as command and control stage of the kill chain. And the final stage is called as action. So in action, it is up to the attacker again. If he wants to steal information, if he wants to modify it, or if he wants to bring down the entire system, he can do whatsoever he wants. So these are the different stages in what we call as a kill chain in cyber defense. So reconnaissance, weaponization, delivery, exploitation, installation, command and control, or CNC we call it, command and control, and action. So these stages are done one after the another. And if an attacker is a skillful person, these stages are carefully planned and executed in such a way that the victim doesn't even know that an attack has taken place. That is how you can actually measure the success of an attack. Nobody knows, nobody even guesses that an attack has taken place if the attacker has done a good job. Next thing we discuss is something called as behavior-based security. Now, usually, I can quote an example. If you have a credit card and you usually spend 1,000 rupees or 2,000 rupees, and suddenly if there is a charge on your credit card, maybe for around 50,000 rupees, automatically the bank company will make a phone call to you saying that, sir, are you going to do a purchase of 50,000 rupees? Is it really you? Why do you think the bank is going to call you for 50,000 rupees charge? Because they know that they have identified an abnormal behavior. They know that your spending pattern does not exceed 5,000 rupees. But if you're spending in one which is completely abnormal for you, they want to double check whether you are the actual real person who is doing it, or a criminal is doing it on whether it is a criminal act. Similarly, that is called as behavior-based security. This is also a form of threat detection that is simply does not rely on malicious signatures, but actually uses informational context to detect anomalies in the network. So if there is some abnormal behavior or an anomaly, you actually pick it up and you can feel that it is an onset of an attack. Another thing which is done by the organization's network administrator is to set up honeypots. Honeypots are nothing but systems which are vulnerable and which the attacker thinks that it is one of the core systems which contain a lot of information about the company or organization, but it is a trap. The network administrators set up these honeypots to lure the hackers into the network and let them think that the attacker has succeeded with its attack and is going to get all that information. But in reality, what actually happens is the administrator can capture, log, and analyze the attacker's behavior while he is working with the honeypot. So honeypots play a crucial role, and almost all the organizations do employ these honeypots to make sure to safeguard their data and also capture what's happening or how the attacker is able to see or what the attacker wants to do with this particular data. And in this context, there is also something called as Cisco's Cyber Threat Defense Solution Architecture. This also uses behavior-based detection and indicators to provide greater visibility, context, and control. The goal here is to know who, what, where, when, and how an attack is taking place. You need to identify these things. There's something also called as NetFlow. As I said, now we need to gather as much information as possible. So Cisco NetFlow is usually employed on most of the Cisco's devices like switches, routers, and firewalls. They come equipped with NetFlow. What it does is it actually gathers all the information that flows through this network. So it contains information like data entering, leaving, and which is flowing through the network. And then this information is actually sent to the NetFlow collectors, which store this information and analyze these records. So based on these records, the NetFlow, maybe within minutes, what it can do is it can actually establish baseline behaviors for the users based on different attributes. So once you collect these behaviors, you will be able to find out if there is any abnormal behavior when compared to the normal behavior of a user. Also, the next term for an organization is something called as CSIRT, which is called as Computer Security Incidents Response Team. I have been saying in the security practices that you have to keep on testing your incident response team. You have to have a team whose specific task is to come into action if an insecurity incident happens or if an attack happens. How do you recover from it? How do you recover from it? How do you stop it? and how do you decrease the impact that it has. All of it is to do with this computer CSIRT team only. Generally, Cisco CSIRT provides proactive threat assessment, mitigation, planning, incident threat analysis, and security architecture review. Now, on top of all these things, we also have a practice of maintaining something called as a security playbook. Even though the name itself suggests it's a book, it's not actually a book. What it does is, it is a list of all the required steps and actions. Now, if the attack or an incident happened, what somebody should do? What are the steps that are need to take in place to learn from that attack, to counter that attack, and to learn from that attack, and to make sure that this attack does not happen in the next play, in the near future. So all those things, all that information is collected and they are put into step-wise format that comes as a security playbook. I told you this security playbook is nothing but it's a collection of repeatable queries, reports against security event data sources that lead to incident detection and response. So what it does, so it has the ability of detecting malware infected machines, suspicious network activity, irregular authentication attempts. Now, if a user is trying to enter his username password 10 times within 10 seconds, what do you infer? What do you infer? That somebody else is trying to do that. All those things are actually caught and analyzed. Then you can actually block their system, saying that too many attempts. So describe and understand inbound and outbound traffic, what sort of traffic is being sent, what type of websites or what kind of information is being communicated to the outside. So provide summary information, statistics, usable and quick access to statistics and metrics. So all this data you need to correlate. So that is what a security playbook does. So just type in security playbook architecture in Google. You can find lots of images on different steps that are involved in creating such security playbooks. There's a lot of steps, huge number of steps. It's an iterative process. It's not just do, done, go. No, it's an iterative type of thing where you keep on collecting data, keep on collecting information, keep on analyzing them, see for behaviors. So get that information regarding an attack. So place it back. So learn from that. That is what a security playbook is. There are the different tools for incident prevention and detection here. The first one is something called as Security Information and Event Management, SIEM. So it is a software, as I told you. It collects and analyzes security alerts, logs, and other real-time and historical data from security devices on the network. That is called SIEM. Second one is something called as DLP, which stands for Data Loss Prevention Software. This is also one of the mandatory things that usually organizations employ. The main objective of having a DLP on an organization network is to make sure that sensitive data should not be leaked. So there should be no leakage of sensitive data, accidental or intentional, doesn't matter. No sensitive information should be leaked outside of the network. So a DLP system may focus on file access authorization, data exchange, data copying, user activity monitoring, and more. So there are lots of DLP systems available. Google, if you need Google on DLP systems, if you want to have more information on this. And also there is something called as Cisco ISE, Identity Services Engine, and TrustSec. This is where you actually control the access to the network resources. You classify the users based on their roles, technician, administrator, worker, based on their roles, and you assign access control privileges based on their roles to the required network resources. Okay, so the next thing is something we talk about is IDS, Intrusion Detection System. There are two things, IDS and IPS. So IDS stands for Intrusion Detection Systems. IPS stands for Intrusion Prevention Systems. Now, IDS is either a dedicated network device or it can run on any one of the security devices already installed on the network. What it does is it contains a large database, maybe database of rules or attack signatures or behavioral patterns, that kind of stuff, and it keeps on monitoring the network for any kind of malicious traffic. So when the traffic comes in, it checks the traffic with its database. Now, if there is a match, what happens if there is a match? Because its database contains all those malicious network signatures or traffic signatures. If there is a match, automatically the IDS will log the detection and create an alert to the network administrator. Please remember that the IDS will never block anything. It will simply detect, log, and report it back to the administrator. It doesn't do anything else. It's a passive kind of thing. Okay. But usually when you have an IDS system on the network, it tends to increase the latency because it has to go through the different packets and incoming traffic, monitor all the traffic, send and analyze. That is the reason usually IDSs are employed outside your network in the offline mode. So whatever traffic is flowing through, they can be copied or mirrored by a switch, forwarded to the IDS, and then if it detects a match, then we can report it back to the administrator. Remember that IDS does not take an active action against any malicious traffic. If it detects a match or if it detects any malicious traffic entering into the network, it will create a log and then report it to the network administrator. It will simply send an alert to the network administrator. On the contrary, intrusion prevention systems, they have the ability to block or deny traffic based on a rule or a signature match. The best known rule set is something called as SNORT, S-N-O-R-T, Google SNORT rules. There are many IPS which work in conjunction with SNORT rules. So the commercial version of SNORT is something called as Cisco's SourceFire. It has the ability to perform the real-time traffic and port analysis, logging, content searching and matching, probing, attacks and port scans. It also integrates with the third-party tools for reporting performance and log analysis. As I said, IDS and IPS main objective is to collect as much information as they can, keep on monitoring the traffic that is entering into the network, see if there is any match in their databases which contains these known signatures or known behavioral patterns. And if there is a match, IDS will send an alert, where IPS, if there is a match to any one of the rule set or a signature, it can actually block the traffic, it can deny a connection. So we have come to the end of this chapter 4. As I told you, this is completely dedicated of protecting an organization. So implementation of firewalls, how do you detect malwares, and how do you detect the attacks in real time? What are the best security practices for an organization? What are botnets? What do you mean by kill chain? What do you mean by behavior-based security? How do you match these things? And what is the main functionality of a CSIRP? And how do you define or how do you implement an IDS and IPS systems? So this particular chapter is completely based on protecting of the organization's data, active and proactive, passive, whatever you can take it, organization's data and organization's assets. So this actually ends our course. Chapter 5 does not have, or chapter 5 is purely based on Cisco's certification programs. So you can go through chapter 5 content. It's only a little bits and pieces content. So these are the 4 modules which are very important for your coursework. So please go through the 4 modules videos and then you can take the final exam. So all the best. Thank you very much for your patience. Thank you guys.